So yeah, I did used to do a lot of CSS work a couple of years ago, and I felt like a bit of a fraud when Gina emailed me asking me to come and speak at Clarity, because I hadn't done much design system work for the last, I'd say 18 months or so now. So like, Gina, are you sure it's going to be appropriate? She's like, yeah, it's fine. I was like, okay, good, that's just a question. You've answered it. Get me on a flight. Get me to Clarity, because I've been wanting to come and speak at this event since day one, and it's a real privilege to be here with you. But I will be talking less about design systems, and by less, I guess, really I mean zero, and more about performance. And today's talk, more than you ever wanted to know about resource hints, and I'm willing to bet it is more than you actually ever wanted to know about resource hints. It's a look at a relatively new performance specification, performance-oriented specification, and how that can help us, no matter what kind of site or app we're building, just help us to make it a little bit faster in a very sort of cheap and easy way. I'm going to perhaps have to miss out a small bit of this talk. There is a longer version online. We'll see how far we get. But if you want to look up the full unabridged slides, there's the link to do so. That's like the fullest possible version of this talk. So I'll just let you get a quick picture of that. I'll tweet that at the end as well, so don't worry too much about getting it now, I guess. Yeah, my name's Harry. I'm a sort of consultant performance engineer. And what I did about 2 years ago is I just decided to refer to myself as the job I wanted to do, right? And just people started hiring me for that. And it's a really good tip, right? If you're going to do something different, just say that's what you do, and the right emails will start coming in. I'm from Leeds in the north of England, which explains the weird accent. And Leeds is a little bit like London, but about 10 times nicer. And apparently, Gina told me this, I'm the first overseas speaker. Dan even doesn't count because he lives here already. So apparently, I'm the first overseas speaker, which is pretty neat. It is my job to help clients. Typically, it's going to be fairly large clients because they will feel the benefit more. I tend to work on a consultancy basis with companies like this. And all of these companies have different needs, different problems. They've all got problems. Different budgets, different timescales, different priorities, etc. But one thing that I would say all of them have in common is they could and usually have all use resource hints to make tangible improvements to web performance in matters of sort of minutes to hours. So that's what I want to look at today, is quick, cheap, very sort of stack-agnostic ways of making websites faster. I also hold positions as an MDE, Media Developer Expert for Cloudinary, a Google Developer Expert for Google, and a Performance Ambassador for Shift. So I do take performance very I get about a bit, don't I? I take performance very, very seriously. So I sort of hold positions with these companies to try and fix performance from the inside out in a kind of an advocacy kind of way. During this talk, we will see different types, different designs of slide. A slide like this is a pro tip, a short summary, something that's going to be really sort of quickly digestible. Conversely, if we see a slide like this, panic, right? There's a bug, there's a regression, there's a caveat, there's a warning. This is one of those slides where you probably have to pay attention to the actual the context that it's in, because there are chances you could implement resource hints potentially incorrectly through no fault of your own, browser bugs, things like that. And finally, if you see a slide like this, it's got a little camera icon in the lower right-hand side. It's probably going to be useful just to snap a picture of that slide so you've got the syntax in front of you, so you can actually view the kind of code that I'm talking about while I step through that section. Of course, all optional, but if you do want to follow along a little closer, that's how I would recommend doing so. Anyway, resource hints. Who has heard of resource hints? Just by show of hands. Okay, actually surprisingly few of you, which makes me look good, right? Of those who put their hands up, who's implemented resource hints before? Anybody implemented resource hints? I'm willing to bet you've actually all heard of them, but just not as this name. This is the formal name for them. As we look through, you probably will be like, oh, I've seen that, I've used that. But a resource hint is defined as a primitive that enables the developer to assist the user agent in the decision process of which origins it should connect to, and which resources it should fetch and pre-process to improve page performance. My God, that is dull. What a dry. I do read a lot of technical specs, right? I had my hand up in the last talk. I read a lot of technical specs. And as thorough as this is, it kind of masks the beauty of resource hints and the simplicity. Because basically, a resource hint is simply a single line of HTML that can dramatically improve the performance of your site or application. And it really is a single line of HTML. We're looking at things like this. The syntax is declarative. It goes in your head tags. We really are looking at things as simple as this. Now, seeing that slide, I'm going to ask again, who's heard of resource hints? Who's seen these before? Yeah, way more hands went up. So resource hints are just a formal name for the specification. I would recommend reading the spec if you ever try and implement these thoroughly or fully or completely. The spec is right there. But I guess the whole point of this talk is that I'm going to distill the spec into its most interesting and pertinent bits for you. First bit of a warning is these are hints. This is actually a very critical part of the name. These are hints. These are suggestions that the browser might be able to do something to speed up navigation, but the browser will ultimately use its own heuristics, its own decision-making as to whether or not it executes these, which makes them very safe to implement. So by all means, start experimenting immediately. We're going to look at 5 resource hints today. There is a 6th one that I've omitted from this talk, just purely in terms of timings. DNS-prefetch and preconnect. The first 2 deal with the scenario where our web page is ultimately going to request resources from a different domain. That's what the first 2 use cases are, or the first 2 resource hint use case is, rather. 3, 4, and 5, these begin to deal with specific URLs. So not necessarily domains, but actual file paths that we're aware of. And specifically number 5, prerender, deals with web pages, so actually URLs for entire pages that we could render invisibly in the background to improve navigation. So let's start at the beginning. Start with DNS-prefetch. I'm starting here because this is probably the simplest, for want of a better word, the most sort of light touch, and I would dare say the least effective of all of them. But we'll start with DNS-prefetch. It is the oldest, it goes back the furthest. And simply, as the name suggests, it will look up a sort of an IP address for you. It will do a DNS prefetch. It will warm up a DNS resolution for you, so that when you need to go to a different domain, we know which IP address it lives at. Use these when you know the domain you're going to be requesting things from, but you don't necessarily know the exact file you're going to need. So you might be linking out to Google Analytics, or you might be linking out to Google Fonts or something, a third party perhaps, where you know you're going to hit that domain at some point, but the exact file might change. The syntax is, again, declarative, very, very simple. Link rel equals DNS-prefetch, and then here we put a full domain. It's as simple as that, and this is going to instruct the browser to start doing some DNS resolution for us. It's got the sort of oldest support, I would say. With 81% current browser support, it's definitely worth implementing. And this is the one you would use if you want to capture IE 9, 10, 11 support. So if you've got legacy browsers, anybody working with IE 9? You lucky, lucky people. Oh, Ethan, I'm sorry, man. I actually do a lot of work with British government, and we only just got allowed to drop IE 7, so that's why I look so disheveled and stressed the whole time. So DNS-prefetch is good if you're dealing with legacy, and I would say a really good use case, an example use case for DNS-prefetch would be you're linking out to a different domain. Now, this is an example from my site specifically. I embed a YouTube video, and it's not until line 155 that the browser knows that it needs to visit youtube.com. And it's at that point it starts opening connections and looking for IP addresses. But this is far too late. This isn't very optimal, right? We want to do this ahead of time. So if I know as a developer that at some point later in the page, I'm going to go to youtube.com, I can give the browser a hint. So when we request a file from a brand new domain, we're going to go through potentially all of these steps. DNS is the first one, TCP, TLS, time to first byte, and then finally the blue is content download. DNS-prefetch predictably deals with the first bit, which is your DNS lookup. And all that is doing is translating youtube.com into this IP address. Now, I want to look into the sort of effectiveness of using these, because a DNS resolution doesn't typically take very long. It's usually quite a quick thing to do. So I did some research. Common names can answer in closer to 80 to 120 milliseconds. An uncommon name could be more like 200 to 300 milliseconds. So what we mean here, common names, uncommon names. A common name is going to be a highly trafficked website, so twitter.com, right? It's going to be in global DNS cache all around the world. But perhaps visiting my site from, I don't know, rural Scandinavia, it's going to be slightly less common. In edge cases, though, for any queries that need to go through a full DNS resolution, like recursive resolver and hit sort of the backbone of the internet's DNS, you're dealing with anywhere between 1 and 10 seconds. What's quite annoying here is the timeframes you're dealing with are anywhere between 80 and 10,000 milliseconds. It's a big gap. We can pay that cost up front. We could use DNS-prefetch to pay this cost ahead of time and make sure that users are getting quicker responses. What you'll see here is a waterfall chart showing that these DNS-prefetch domains, that small bit of green, that DNS cost, has been removed from the rest of the connection, right? Here we're making tiny, tiny, tiny savings, almost so small as to not be worth it. What you'll notice is the one here, the one beneath the last red arrow, that's managed to detach the whole thing. We're not just doing DNS ahead of time here, we're doing a bit more. We're doing TCP and TLS. So that's what we're going to look at next. If you are working with IE9, DNS-prefetch was implemented as prefetch in IE9, which means that if you want to use actual prefetch in IE9, you're going to accidentally do a DNS-prefetch instead. It wouldn't be a nice, exciting feature without some kind of IE quirk, so it's to be expected. We'll come back to that in the prefetch section, because it does render prefetch proper completely useless in IE9, but we'll come back to that in the next section. Or one of the next sections, sorry. So preconnect is like the better, I would say, is the better version of DNS-prefetch. DNS-prefetch only does DNS, whereas preconnect will step forward and it will do the TCP, and hopefully, if you're running a secure connection, which we all should be, it'll do the TLS negotiation as well. And again, it's when you know the domain but not the URL, and the syntax, again, very, very familiar. This time we're just swapping out DNS-prefetch for preconnect, and the href here points to a domain. It does not point to a file, it points to a domain. Support for this is interestingly better. There's better support for preconnect, despite it being newer than DNS-prefetch. So to this end, what I would recommend is, unless you actually have to support old IE, don't use DNS-prefetch at all. Just go straight in and use preconnect. And as I said, this will do the next two phases as well. So it will do the DNS as part of the connection, but it will then do the next two bits also, your TCP handshake and TLS negotiation. What we're dealing with here is actually quite a lot of cumulative time. To open a secure connection to a domain in theoretical best possible going over fiber optic connections or cables, this is the best case scenario, opening a connection from London to New York or vice versa. What we're doing here is we're dealing with an extra 168 milliseconds of time. And we can do that ahead of time off of the critical path. And 168 milliseconds, that's best case, theoretical best case, speed of light scenario over fiber optic, London to New York. What's typically going to happen is it'll be much slower than that. And even if we were to double that to roughly 300 milliseconds, you're probably thinking 300 milliseconds is probably not enough time worth saving. I would have agreed with that also, like before I really got sort of entrenched in this kind of performance industry. I worked with a client in the UK called Trainline, and Trainline worked out that if they could save just 300 milliseconds of latency, customers would spend an extra £8.1 million a year. Finding these like hundreds of milliseconds actually becomes really trivial with resource hints, right? A single line of HTML could save us close to 200 milliseconds, and that's accordingly going to be like millions of pounds for these kind of companies. A little aside, I didn't tell them how I found them this 300 milliseconds, because I couldn't say, wrote one line of HTML, here's an invoice of £10,000, done. Pro tip, never tell your clients how you do things, just tell them what you did and what it led to. And if anyone's interested, this screenshot, this diagram was stolen straight from my favorite technical book of all time, High Performance Browser Networking. It is available for free online, hpbn.co. Best technical book I've ever read, and it is, like I say, completely freely available. Now, the effect of preconnect can be quite dramatic. This is my site, or a waterfall of my site before I implemented preconnect. This is years ago, right? This waterfall is from 2015, perhaps. What you can see here is a bunch of these files have got these long connection overheads happening just before we download the file. And this is the most inopportune time to solve these problems. By simply adding a handful of lines of HTML to my head tags, I could divorce that overhead, the latency overhead, from the file download completely. Here I'm paying off hundreds of milliseconds of latency completely for free and out of the way of the actual assets that I need to download. So this can have huge, huge savings in almost all circumstances. If you are having to hit older browser support, you can do preconnect with a DNS-prefetch fallback. The nice sort of syntactical sugary way of doing this would be to actually load your rel attribute with 2 values, because this is completely valid HTML. Your rel attribute can take multiple values. This is a nice terse way of doing things. But the bad news, this flat out just does not work in Safari. In Safari, it's valid syntax, but this just does not work. So if you want this working in Safari, you're going to have to do things a little bit differently. This is a waterfall that I keep forgetting to remove this diagram because this tells you nothing. You just have to trust me that what I'm saying is this shows it doesn't work in Safari. It's a bit of a pointless diagram. This is an exercise in trust now, right? There's a bug open. This is going to get fixed. It's temporary. But for now, if you want to hit both, if you want this to work in Safari, sorry, you're going to have to swallow this bit of redundancy. It's annoying, but we can live with that. Interestingly, what you're going to need to do is put your preconnect first, so that browsers that support preconnect will do that. They will then skip over the DNS-prefetch. If you had these the other way around, the parser is going to find the DNS-prefetch, do that first, then it'll find the preconnect and have to do that as well. So put them this way around. It's the quickest way of achieving it. Advice here would be judicious with preconnect. Be careful with what domains you're preconnecting. If you find that your head tags end up with 25 preconnects in there, that's going to be a good litmus test for the fact that you're probably linking to too many third-party domains anyway. So the amount of preconnects you have is a good proxy for how bad your third-party problem potentially is. But also, there are some technical reasons why we shouldn't go preconnecting everything. What I'd recommend is finding the most critical, significant, and likely domains you're going to hit. So that's going to be Typekit, it's going to be Google Analytics, it's going to be Optimizely, it's going to be Cloud Enemy, it's going to be things like that, the important ones. Don't warm up fourth, fifth, and sixth party domains. So when you talk about third-party performance, your third parties have probably also got their own third parties and so on. Don't go warming up any fourth, fifth, and sixth parties, because that's just wasteful, right? We don't want to do that because we want to prioritize immediate content first. Also, opening too many connections has a CPU and battery overhead. Devices keeping TCP connections open can have, certainly has a resource overhead. It may be slight, but certainly on older feature phones, keeping a lot of connections open can be costly. And then weirdly, the last point on here, if anyone buys me a beer, I'm not going to, I mean, this is getting recorded, so I'm not going to out the Chrome team, so I'm not going to say it publicly, but it's a very weird, it's a feature, not a bug, in Chrome. Chrome can only conduct 6 simultaneous DNS resolutions at a time. This has got nothing to do with TCP connections and 6 connections to a domain in HTTP1. This is literally at DNS resolution level. Chrome can only do 6 lookups at a time, and if you buy me a beer, I will tell you why that is. Bad news. In Firefox, actually, it's not all Firefox. In Firefox 66, if you implement preconnect, it is just not going to work in Firefox 66. It just regressed. There's no real reason why that happened, but this was detected when someone was trying to implement preconnect, doing their browser testing, and realized it just wasn't working in Firefox. And after much kind of hair pulling, they realized that actually there was a bug, and preconnect got dropped from Firefox 66. No one's quite sure why, but there's been a bug to reinstate it. It's back now, but it's just something to be aware of. OK, so both of those examples dealt with the scenario that we know this page that we're building needs to visit an external domain, but we don't necessarily know which file it's going to be, or it could be many files. For example, the YouTube embed that I used, if a page has got several YouTube embeds on there, you can't go necessarily prefetching all of them. You would just do the DNS or the preconnect for the YouTube domain. However, in the scenario where we know which file we're going to need, we know the exact URL, we can begin to use the next suite of resource hints. And the first one of the next suite is prefetch. Actually, quick show of hands, is anybody working on a client-rendered JavaScript application? Mm-hmm. Yeah, unsurprising. There's a nice use case for prefetch if you're building single-page applications. We'll cover that in a second, but you can do preemptive fetching. So if you do root-based code splitting, you can, from whatever root your customer is currently on, you can preemptively load the subsequent route in the background. If you're using specifically Angular, you can do that with a tool called guest.js, which is like a nice, intelligent way of doing what we're about to talk about now, which is called prefetch. So prefetch is technically defined as a file needed for subsequent navigation. I often think that spec writers would make really great lawyers, because they're always good at being sort of vague while capturing every edge case. What I want you to think about when you read this is it's a file needed for the next page, right? However, the sort of vague way of wording this is it's a file needed for subsequent, so not necessarily the next page, but subsequent, and not even page, but navigation. This is written in a way that this has to work with single-page apps where you don't have pages. So the spec is intentionally vague that makes sure that this works with SPAs. The syntax is, again, going to look really familiar, declarative, in your head tags, But this time what you will notice is we're not linking to a domain, we're linking to a specific file. This file could live on another domain. By all means, that is possible. But mainly what we're looking at here is the fact that we're pointing at a specific resource, a JavaScript file. Support for prefetch sits at 82%, so again, absolutely worth using. And a good use case I have for prefetch, an example I use, imagine we're working for YouTube. And we're the developer currently working on building the search results page. And somebody's searched for cute cat videos, and they've got a list of thumbnails. And as a developer, we are 90% certain, probably 95% certain, that a user is going to click one of those thumbnails and proceed to watch a video. What we can do is make the decision from the search results page, we can make the decision that, well, let's prefetch the JavaScript needed to run the video player. Let's not wait until they're on the video page to load that JavaScript, because any delays is going to delay their time to actually clicking play. From the search results page, while they're scrolling through and deciding which video to pick, let's download the videoplayer.js file in the background so that by the time they're ready to watch a video, the JavaScript is there in browser cache already. So from the search results page, all we're going to do is prefetch that JavaScript file. What this is going to do is download the file and drop it into HTTP cache for later usage. HTTP cache is basically what we talk about when we refer to browser cache. The spec has this to say about it. The user agent should not apply preprocessing on the response and must not automatically execute it or apply it against the current page context. What this basically means is the file will get downloaded, but it will not run. It will not execute. So again, it makes it very, very safe. It will not execute once it's downloaded. It will only execute when the page that needs it calls it up for use. So it's downloaded by the prefetch, but it will be actually executed by the script tag or the import or whatever sort of loader we're using. So it just drops the file into browser cache. Prefetch will not execute it, blah, blah, blah. It will drop it into HTTP cache, except, and this is where things get a little weird, well, the first half is actually quite predictable. If the file has a no-store cache control header or a must-revalidate or a no-cache control header, that will revalidate the asset against the server, and it will also do the same if it's more than 5 minutes old, which seems like a really arbitrary line to draw in the sand. But if you prefetch a file, and then 5 minutes later the user still hasn't used it, when they eventually load that page, it will get revalidated. So prefetch is really only good for 5 minutes. So what this means is tread carefully. If you know that users are going to be clicking through the site and they might not be getting to the checkout page for your average session durations more than 5 minutes, for example, this will start to become less effective the longer a user doesn't go to that sort of page that needs it. 5 minutes seems fairly arbitrary, but them's the rules. Prefetch is fetch with the lowest possible priority. This is by design. This is very important. Because it's a file needed for a subsequent navigation, there is no way on earth that the browser should interrupt the current page's performance to prioritize a subsequent asset. So what tends to happen is as soon as the network becomes idle and the browser isn't doing any heavy lifting, it isn't using the network, the file will get downloaded almost lazily at the end of the current page's sort of load event. A thing that I was quite interested in, what happens to a prefetch? Did that skip to? No. What happens to a prefetch if it doesn't get fully downloaded while you're on that page? So for example, we're on page A, and we start prefetching a large file, and the user leaves page A and goes to page B before the prefetched file finishes downloading. So my question was, is the browser going to just cancel the download and then restart it on the next page, so you download the first half twice? Or will the browser continue that download across page navigations? Turns out this is a really difficult question to answer. You have to actually look at the network level, like TCP, sort of take a TCP dump and look at the actual sort of stack trace of what's going on the network. But I eventually found out that browsers are pretty smart. If you start a prefetch on page A and navigate to page B before the prefetch finishes, the browser will just continue. The browser will keep that download going in the background, so you don't get any wasted bytes. You don't get any double downloads. It won't cancel anything. I mentioned this previously. Prefetch acts like DNS-prefetch in IE9. It'd be a silly idea to standardize these things, wouldn't it? So they didn't. Prefetch acts like DNS-prefetch in IE9. So if you're trying to implement prefetch in Internet Explorer 9, all you're going to get is actually a DNS warm-up for this file. The file won't download. The domain will just get its DNS looked up. Again, that only applies to me and Ethan in this room. We're the two IE9 people. Next, we're looking at preload. Preload is an interesting one. Preload actually technically is no longer a resource hint. Preload became a mandatory fetch. So it was moved out of the resource hint specification, and it actually has its own spec just called preload. The reason for this is that preload is a high priority fetch for a file needed for current navigation. And because it was made mandatory, it is no longer a hint. So this is where you do need to tread carefully. This is the one where you need to be a little more aware and a little more careful about how you're implementing things. Prefetch is a mandatory fetch for a file needed for current navigation. Basically, there's a file that will be needed on this page, but the browser's not going to find it till quite late. So what we can do is give the browser a hint, or it's not even a hint, I'm just sort of explaining that. It's a mandatory thing saying, hey, you will need this file soon, go and get it early. It's a way to surface late-discovered resources, and again, if you're building a single-page application, this is going to be quite useful to you if you're building a client-side sort of JavaScript application. It's a good way to surface late-discovered resources, and I'll come back to what exactly a late-discovered resource is shortly. But another thing to be aware of with preload is the syntax does begin to differ. It doesn't get more complex, there's just more of it. So the first line here is pretty familiar. Rel equals preload, path to a specific file. The second line, we get these new attributes that we haven't seen before. I'll talk through what each of the attributes does and what it's used for in a second. But preload is probably the least, or one of the least supported of all of them. As you can see here, it's mainly just a blink thing. In fact, this needs updating a little bit because now that Edge has moved over to Chromium, supports obviously better. But preload is the least well supported that we've looked at so far. So yeah, what is a late discovered resource? Loading web pages is actually really inefficient, which is good for me, I guess, because it keeps me in business. Lots of web pages have what we refer to as late discovered resources. A web font is a great example of a late discovered resource. A font would be a great example of a late discovered resource. We download some HTML, which in turn asks for some CSS. We build the render tree, and the render tree then says, oh, actually, we need a font for this page. This particular heading is Gotham, or the page is Open Sans. The font here is what we would consider a late discovered resource. Same thing with a background image. The background image isn't surfaced until the CSS has been parsed, built the CSS on, built the render tree, and the page then says, oh, this div needs a background image. So these late discovered resources can push back page load times quite significantly. If you are building a single-page app and you haven't paid very close attention to this, a single-page client-rendered JavaScript application is a really quick way to build a really slow website. HTML is going to request some JavaScript. Your JavaScript builds the virtual DOM, which may inject some styles, or the CSS OM can naturally be applied to the virtual DOM. Then builds the render tree, and then we find out, oh, look, we need a font. It's kind of late now. We're getting all this stuff stacking up, and we're pushing these load times and these start renders back even further. The good news is preload is going to help us out here. Preload will help us take the edge off of this. As developers, we know that we're going to ultimately go and find this font. The browser doesn't know that yet, because the browser doesn't know that until it's done all the other work. So what we can do is use preload to tell the browser, hey, while you're downloading app.js, please preload my CSS file and preload the font that is going to be inside of that CSS file. This helps fix the SPA problem. We now get ultimate parallelization. Things are going to be way, way, way quicker. So preload allows us to parallelize all this work, and we just shaved off hundreds and hundreds and hundreds of milliseconds there, all by adding 2 lines of HTML. So I'm going to quickly whiz through the extra attributes. We saw the as attribute make an appearance. The as attribute used to be optional. You didn't need this attribute for preload to work, but at some point the specification changed, and the as attribute is now completely mandatory. The as attribute is used to set priorities, it's used to set request headers, and it's a predefined value. You can't invent a value for this attribute. It's going to be one of these. The attribute is necessary to guarantee correct prioritization. So if you've got several preloads, one of them's for a CSS file, one's for a font, and one's for an image, basically, CSS is more important than fonts, is more important than images as far as the browser is concerned. So what the as attribute allows the browser to do is prioritize the network utilization and the requests for these assets. So with the as attribute, we will see that the priority of files gets set accordingly, highest for CSS, high for JavaScript, low for images. I can guarantee already that a few of you in this audience, because we all fancy ourselves as like hackers, I know I certainly do, you're trying to be sneaky and think, well, hang on, if I need to download an image, can I just preload an image as a CSS file and trick the browser into over-prioritizing it? Unfortunately, that isn't going to work. So if you start with syntax like this and try and just tweak it around to kind of mismatch, you're going to make things much, much worse. You're going to start to get double downloads for all of these assets, and this is going to be a harmful thing for performance. So make sure you're using the as attribute, and make sure you're using it properly. Also, yeah, if you do want to sort of think about how you trick the browser into doing things even faster, there's a spec that is, it's only live in Canary, and I believe it's behind a flag in Canary. In fact, it's basically still a sort of a little glint in Paul Irish's eye still. Priority hints is super new, but what this will ultimately give us is the ability to drop the importance attribute on any asset in our page. So download the masthead with a high priority, but our lazy-loaded asynchronous CSS, download that with a low priority. So the priority hint spec is going to help and can sit in tandem with resource hints. The type attribute is optional. You don't need the type attribute, but it can be useful in any contentious scenarios where a browser might support preload, but doesn't support the file you are trying to preload. And a good example of this would be Safari. Safari supports preload, but doesn't support WebP. So you don't want Safari to download this image at all. So if you've got these scenarios, and they're very few and far between, WAF2 is another good example. Any new file, new sort of next-generation file formats that a browser doesn't support but would end up preloading, this is a good opportunity to use the type attribute to tell the browser not to bother. The cross-origin attribute. Anybody know much about cause and cross-origin? Look at all those people so much smarter than me. I've got no idea. I read about cause, I'm like, I still don't really know what's going on. I'll just type it until it works. But if you've got any cause-enabled resources that need to be fetched anonymously, you use the cross-origin attribute. Fonts usually need to be, even if fonts are on the same origin, they need to be fetched with a cross-origin attribute. There's loads of weirdness about cross-origin and cause. Like I say, I can't really explain it too well to you. I think I'm demonstrating that right now. So my tip when you're implementing preload is just keep an eye on console. In Chrome specifically, in their developer tools, it gives you really good guidance and insights as to what might be going wrong. So the example I've got here, I built basically the worst possible preloaded page. For the first error, it's because I'd missed out the as attribute. I just didn't use it at all, so that file was double downloaded, wasteful. The middle error, the second error, oh, this is actually really smart. I forgot about this one. If you preload something, but the page never ends up using it, the browser will warn you. It'll say, hey, look, you preloaded an image, and you never actually used it, so don't preload it. You're wasting bandwidth. And finally, I loaded a font without the relevant cross-origin attribute, and Chrome just told me. So I don't need to learn about cause. I probably should, but I don't, because Chrome tells me what to do. So keep an eye on console anytime you're implementing resource hints. Oh, speaking of Chrome, right, they give with one hand and take with the other. So Chrome is really useful, but it also gets preload really badly wrong. Wrong enough that I'm actually reverting it from a lot of my clients' projects. Preload is actually kind of, to an extent, detrimental in Chrome currently. It's being fixed, but there are huge problems with preload, specifically in Chrome, serious enough that I'm actually taking it back out of client projects. So sorry about the bad news. Chrome inadvertently over-prioritizes preload. So preload is pretty important, but your CSS is critically important. But what Chrome ends up doing is it ends up downloading your preloads before other assets. It's kind of a painful irony that you're trying to make the site faster, and you can ultimately make it slower because Chrome will misprioritize what you're requesting. I'll show you the exact sort of phenomenon with a diagram. Here we've got a waterfall chart as a project by my friend Andy Davies. And what you can't see, what none of us can see, is ultimately this site, this page, is going to download some web fonts. And the web fonts are probably somewhere around here. Those web fonts are going to be blocking text rendering, so we want to download them really quickly. So Andy implemented preload to get those fonts sooner. Sure enough, the fonts now jump up to the top of the request queue, but something bad's happened here. Those fonts have been requested before our CSS. They arrived before our CSS. So here's a pro tip that I usually go through with sort of workshop attendees. Looking at this waterfall, we can see all the requests started at the same time, which is good, right? But really, what we need to be looking at is when the requests finished and when they became useful. What you'll notice here is that the fonts arrived before our CSS. They stole bandwidth from the CSS files. The painful irony is a font is useless without the CSS to apply it to the page. So Chrome inadvertently over-prioritized the fonts, delayed the more important CSS, and made this site 400 milliseconds slower. This is a real painful irony, and it's really annoying me because there's no workaround. So for the last sort of 6 to 9 months, I guess I've just been going around removing preload from client sites because of scenarios like this. It's a shame, but it's being fixed. If you buy me another beer, I'll tell you why it does this. Right, last one, prerender. This is like the final boss. This is the big one. And prerender's a pretty interesting, tumultuous tale, because it's had a bit of an interesting history, especially in Chrome. So all the other things we're dealing with, either domains or individual files, prerender now deals with specific pages. It allows us to download and build entire web pages invisibly in hidden tabs in the background while the user is waiting, or while the user is otherwise occupied. Kinda. Like, not really. It is kind of complicated. It's kind of come and gone and came back again. The way prerender did work, was designed to work, was very simple. Just prerender and a path to a specific page. What this will do is it will go off, and in the background, while the user is currently occupied on the page they're on, it will go and get the login page, it will render it, it will think, oh, OK, this page needs a custom font. This page has a separate CSS file for doing custom form elements. It's got X, Y, and Z, and it'll go and get them all. What we'll find is that browser support for pre-render is actually the worst. It was pulled out of a lot of browsers and sort of like killed off and then brought back again. What I think is quite damning is that it never got ported from IE 11 into Edge. And that's quite interesting because it's kind of harmful, right? They pulled it out for a reason. It's a bit of well, it's not controversial because it's just true. A lot of things around web performance and the web platform have really rushed out of the door over the last few years and not really thought through enough. Prerender is a really good example of that. It posed massive, massive security threats that no one had really foreseen. I'll cover those problems in a second, but basically, cast your mind back to my YouTube example. Previously, a user was on the search results page, waiting to select which video they were going to watch, and we downloaded the JavaScript file for the video player in the background. Pre-render, you go one further. You can say, no, go and download the actual video player page and start downloading the assets, the thumbnails in the sidebar, the actual MP4 that we're going to be streaming. Start downloading all this stuff. You can kind of see where this is heading, right? Inadvertently downloading an MP4 in the background, and a user doesn't know it's happening, and they're paying for their data, perhaps, gets expensive. So they killed it. RIP pre-render. It's actually pretty morbid. I work in a co-working space, and I was like, I need to find a Creative Commons picture of a grave that I can actually put pre-render on. But yeah, they killed it. It's dead. It's problematic. Immediate problems are the technical ones. Huge memory footprint. You know when you like restart your machine and you've got to open 50 Stack Overflow tabs and your fans start whirring? If a developer isn't careful with this and they're pre-rendering their entire website in the background, it's effectively like having a device open N tabs in the background. The user can't see them. All of a sudden, Chrome's using 10 gig of memory. Not just Chrome normally. It's using 15 gig of memory now because you've ended up preloading or pre-rendering an entire website. So bandwidth usage spikes for both the user consuming the data, but also the site sending it. Because it renders a page, it's actually going to build things. So all of a sudden, ad impressions start. Well, actually, no, that's good for us, right? Money. But like analytics hits go up. A user visits one page, but we've rendered 5 in the background. We've just times 5'd our analytics traffic, right? Artificially and inadvertently. Like I say, though, if we're running ads, that's pretty sweet. Just times 5 our ad impressions. What happens if there's a timer, or an interstitial, or an HTTP auth box, right? And it's in a hidden tab? You can't deal with that. You know when you're buying sort of concert tickets online, there's a timer that stresses you out saying, oh, only 15 minutes, your tickets are held for 15 minutes. If that page was rendered in the background, is it fair to start the timer in the invisible tab, or does the developer have to write extra logic to wait for page visibility to then start the timer? Security, right? What happens if we're running an insecure website, or if somebody is running an insecure website, and they get man in the middle, or person in the middle? I think monster in the middle is what they're saying at the moment. They get monster in the middle, and someone injects a malicious pre-render into the page. All of a sudden, the innocent-looking restaurant website that you're browsing has been monster in the middle, and it's got a malicious prefetch, and somebody's mining cryptocurrency on your device in a hidden tab. You've got no way of knowing that's happening. Understandably, they killed it, right? They sacked it off, they got rid of it, they killed prerender. Kind of. So they brought it back. What they did this time is really annoying. They didn't call it anything snazzy, like it's pre-everything, right? Prerender, prefetch, preload. It's now called NoState Prefetch, which is the dullest, most boring thing. So now it's called NoState Prefetch. So actually, it's pretty smart, really. I'm just having a bit of a dig. Because loads of people started using and relying on prerender in the wild, just killing it off would mean that loads of sites that thought they were getting these potential wins just had that snipped off. All of a sudden, this optimistic, this sort of opportunistic optimization just disappeared. So what Chrome engineers did is they re-implemented the mechanism but kept the same syntax. So prerender is now referred to as the API. So the syntax link rel equals prerender will actually still work. It just works differently. And what's different is prerender, the mechanism, is now called NoState Prefetch. And that's what sits under the hood. And that's what I'm going to talk through the next few minutes, is what prerender does now. Or rather, to start with what it won't do, prerender won't render anything, which is a bit annoying. So NoState Prefetch is actually really interesting. NoState Prefetch acts like a recursive regular prefetch. So just think of it as a recursive prefetch. Prefetch is the one where we're on the search results page, let's prefetch videoplayer.js. Or somebody's on in fact, this is what Netflix did, right? If you remember reading a case study, Netflix moved from client-side React. They server-rendered their login page, so it was nice and fast. While the user was logging in, they were doing a prefetch for app.js, vendors.js, massively improved performance. So that's what prefetch does. What prerender now does is it acts as a recursive prefetch. So what you can do is link rel equals prerender homepage, page B, and the browser will open page B, and it will go through and it will just download all of page B's sub-resources. It won't render the page, which means no security implications. It won't execute any of the JavaScript it downloads. It won't start running timers. But what it will do is it will download all of the assets it finds within page B. So yeah, link rel equals prerender, path to a page, and this again will all just be downloaded off of the critical path with the lowest possible priority. So what this means is we can't actually pre-render pages at all, but this, in fact, I'm going to switch back to the syntax. This is like an entry point. This is like saying, hey, go and get this page as HTML and just read through it and get me the stuff contained in there. That's like a shopping list, right? So we're going to send the browser off to a recursive prefetch. What you'll see here is this waterfall. This is me loading. I've got a little sandbox cswizardry.dev website. I just made a page that will go off and pre-render my cswizardry.com homepage. The blue line is the load event. What's happened there is the load event has fired. The browser's realized that, hey, I've got some spare time now. I'll go and just work through this other page I've been told about, and it recursively grabs all the sub-resources. So this speeds up navigation without having any rendering. Rendering, memory footprint, etc. Ooh-wee. Right, so 43 minutes in. I'm going to whiz through the next section fairly quickly. I just want to show some tips and tricks and some gotchas and some cool things we can do, some unusual things we probably shouldn't do. Tips, tricks, and gotchas. All of these can be deployed as HTTP headers. So we've currently looked at the easiest implementation, which is just a link rel equals preload. As designers and front-end developers, we've pretty much all got access to the head tags. If we're looking to have sort of server-level, ops-level, CDN-level access, we can begin to deploy any of these headers, any of these link rels as headers. Google Fonts do a really nice job of this. Whenever you link to fonts.googleapis.com, the response style sheet comes with a header which says, next, this user is going to need to go to fonts.gstatic.com. Let's pre-connect it. This is a really smart optimization that Google Fonts as a third-party provider make for their customers, well, for the end user, really. I wish more third parties did this. Me and my buddy Andy, so Andy Davies is another British performance engineer. There are two of us. We worked together, there's more than two of us. We worked together on a client project, and we had a pre-connect inside the head tags. Then we thought, well, let's see what happens if we put that pre-connect actually in a response header. Andy's definitely more the back-end guy, so he implemented that. And what we found that in the real world, we had about a 400 millisecond improvement at the 50th percentile but more than a 1-second improvement in start render at the 95th percentile, just from moving one thing from an HTML head tags to a link response header. Weirdly, Edge only supports HTTP header version of preconnect. This really annoys me because putting stuff inside head tags is a nice accessible way of doing things. Flat out will not work in Edge if you're trying to do a preconnect. So Edge will only accept an HTTP header. Conversely, Edge doesn't support the HTTP header for preload. This is probably going to be changing as they move more in line with how Chrome works. So obviously Blink is the rendering engine, but Chrome itself works a little differently. What's next? Oh, this is sweet. We can generate these dynamically. You can create these resource hints with JavaScript dependent on user input. And the best, nicest, quickest way to do this is a tiny little open source library called instant.page. Has anybody heard of or used Instant Page? Okay, I would really recommend, 2 of us, nice. I would recommend dropping this into a site and just seeing what happens. It can have tremendous benefit. I'm going to play a little GIF. Look at the head tag, right? As I hover these links in my page, we're seeing this prefetch. Do you see it was getting updated dynamically? As I hover a link, the browser's prefetching stuff. Now when I visited my own case studies page, that file downloaded in 3 milliseconds from disk cache. We're doing pre-browsing. There's a configurable sort of cutoff point, so it's like if you pause the cursor for 50 milliseconds, that's an intent to click, and it'll go off and prefetch the next HTML payload. But the only problem that I foresee with this is if you're a site that is prone to dramatic spikes or increases in traffic, or it's Black Friday, for example, you need a kill switch. You need a way to turn this off in live without a deployment. We implemented this on an e-commerce client site, and front-end time, front-end sort of all the RUM data for front-end performance was really favorable. Stuff's way faster on the front end. But of course, if you've got a mega nav with like 50 links in it and a user scrolls down all of them, the back end has to build 50 dynamic responses. As an e-commerce site, every page is dynamically built. It's not served from the edge. It's not statically rendered. It's basically a dynamic page hitting the database. We saw New Relic spikes in traffic. As the site got busier and busier, we were hammering sort of the back end, fulfilling these responses. So what you need is a feature switch in live where you can just disable this stuff without a deployment. I mean, nothing worse than Black Friday hitting, and all of a sudden you go offline and you need to deploy to turn this off. So that's just a bit of a cursory warning there. Brad stood on the edge of the stage, looked like security, so I think that means I need to hurry up. And the last thing, what I'll do is I'll skip the next section because you can read that, the slides are online. You need a scheme, and I see people getting this wrong all the time. Theoretically, the top should work. In order to pre-connect an origin, all we need to know is the domain name. We don't really need to know what scheme it runs over. But because this is HTML, the href attribute requires a scheme. So what the top one will do is it will just try and find a file next to the current page, and it will try pre-connect a file that doesn't exist. So basically, what's the equivalent is the bottom line. So you just need to do this. Make sure that whatever domain you're pre-connecting has the correct scheme. 9 times out of 10, well, statistically 50% of the time, but most of the time, that's going to be HTTPS. OK, what I was going to do is have a little demo of all together. Until Brad actually just rugby tackles me off, I'm going to try and do this. If you want to implement resource hints, I'm going to step you through the process of getting a really effective and fairly bespoke strategy in place. Identify a key page. It's probably going to be the home page, perhaps. On an e-commerce site, it might be a category listing page. Audit all of the origins and assets on that page. Which important third parties do we go to? That's going to be things like Google Fonts, Typekit, Google Analytics, Optimizely, Cloudinary. Find all of those origins. Assess likely user journeys. Where might the user go next? And then design a bespoke strategy around that. So on this page, I can't draw. For some reason, I decided to draw my little sketchy bits for this talk. But yeah, we've got a page. We've got a web font. That's going to be critical for rendering the page. The first 3 search results, statistically, are probably the first things to be clicked. And our images are all hosted on, for example, Cloudinary. So these are critical third-party resources. When we click through, we've got the web font again. These top 3 images in the carousel are probably the sort of first ones to be clicked. Again, the green, the image, is hosted on Cloudinary, for example's sake. And finally, we've got a JavaScript image gallery. With all this information available to us, we can decide that, well, let's pre-connect Cloudinary with an HTTP header. That's our third-party image host. Let's do a regular sort of head tags HTML pre-connect for other third parties that are potentially less important, such as analytics, etc. Preload to discover the web font sooner. So a web font is a late discovered resource. Let's pull that up the request queue. Beware of Chrome. Gallery.js is only needed on the product detail page, so let's prefetch that from the search results page. And finally, we can pre-render or prefetch wherever we think the customer will go next. So putting it together, the HTTP response header for Cloudinary would look as something like this. And in your head tags, we need to be adding, pre-connect your other third parties in the head tags with a dns-prefetch fallback. Preload that web font, prefetch the JavaScript for the next page, and then the first 3 search results, we can actually just pre-render those completely and get that HTML on the device much quicker. Altogether, it looks a bit like that. I apologize that last section was a bit of a sprint, but the slides in full are online, actually at the next slide as well, so the URL is going to be on the next slide. But if you've got any questions about this, as you've probably gathered, I will not shut up about it if you ask me, so find me in one of the breaks. That was a little whirlwind tour of probably more than you ever wanted to know about resource hints, and I want to say thank you for being very patient with me. Thank you.